In this phase, my dear students, we will discuss indeterminate forms and L'Hopital theorem, not L'Hospital, which we often do. It has mainly of 5 forms. One is infinite. What the form is? Logic is, if limit x tends to ax by bx, that may be of the form either 0 by 0 or infinity by infinity. In this way, I can differentiate numerator and denominator, cancelling common factor, then arrive at last till we get a finite limit. I repeat, it may be in the form limit x tends to ax by bx, so a is a function, ax is a function of x, bx is a function of x, and there is no common factor between ax and bx, all are eliminated. For infinity by infinity and 0 by 0, I have to differentiate numerator and denominator with respect to x, and just like this, a dash x by b dash x. If it is even 0 by 0, again differentiate, go on till at the end you get a finite result. This model is valid for the first two things. And for third, infinity minus infinity, it can be made of the form 0 by 0 or infinity by in this way. Infinity minus infinity, this can also be done infinity by infinity after algebraic manipulation. This also like that can be made in this form by algebraic manipulation. With respect to the last three forms, 0 to the power 0, 1 to the power infinity, infinity to the power infinity, I have to put y equal to, we have to done in the problems are like that, limit x tends to ax by whole to the power bx, limit x tends to a, and this is either of 0 to the power 0, 1 to the power infinity or infinity to the power 0. I take log both sides and then go on the problem in this way. Then you will observe, by after algebraic manipulation, this thing belongs to either infinity by infinity or 0 by 0. Let us do a simple problem to understand this. Let us take a very simple case with which you are habituated, sin x by x. You can easily understand sin j0 x0. This you have done many times in your class 12. This is 0 by 0. Then I go limit x tends to 0. I differentiate of sin x is cos x, and differentiate of with respect to x, and differentiate dx of x equal to 1. Now I put cos 0 is simply equal to 1. But that is not valid for cos x by x. This is important to remember. Cos x by x, cos x by x, limit x tends to 0. Here we will realize, when I go to do it, expansion is needed, and we will realize later on that x equal to 0 is the pole of the system, not 0 of the system. Cos 0 is 1, 1 by 0 was infinity, and I cannot do it in that way. It can be done. Actually it shows that x equal to 0 is simply a pole of the whole system. I now introduce the values of poles and zeros in this connection, very important. Suppose I say, without taking the limit, just write a very simple thing. Let us fx x minus 1, x minus 2 by x minus 3 into x minus 4. X equal to at x equal to 1, it is 0, the fx. X equal to 2, it is also 0. But x equal to, these are called the zeros of the function. Whereas at x equal to 3, it is goes to infinity. X equal to 4, it goes to infinity. These are called the poles of the function. With these zeros and poles, which can generate from the very basic limit of class 12, are extremely important consequence in circuit theory, in communication networks, in control system, and many things here. Actually, in this case, we say limit x tends to 3. When I put x equal to 3, this goes to infinity, and we say the limit does not exist. Actually, it is a pole. We can do more problems, but most important concept is there are 5 things, as I have told. For number fifth, this is the basic model, but all of them some way or other by doing algebraic manipulation can be reduced to either infinity by infinity or 0 by 0, so that you can start with the model, go on differentiate numerator, differentiate denominator, cancel common factor till you get a finite result. And together with the concept on poles and zeros, which are really important in the real sense of the term, you can get more problems. But remember, in mathematics, simple talking is useless until you can do. Practice will make your hand algebraic nice, and hand will be ready for do any type of indeterminate form which needs Hopital theorem for its finding out the final limiting values.